Hi everyone, welcome to my channel. I would like to teach kinematics of linear motion today. 8.1, displacement, velocity, and acceleration as a function of time. First of all, let's talk about displacement as a function of time. Okay, distance is a scalar quantity which has magnitude only, and the definition of distance is the total path traveled by an object. So let's say they will ask you to find the total distance traveled by an object from the third second to the sixth second and so on. And your answer for distance will be positive. Let's say the distance is 9 meters. Whereas for displacement, it is a vector quantity which has direction and magnitude. And the definition for displacement is the distance of the particle from the fixed point, usually fixed point O, measured on a certain direction. So let's check this diagram. Let's say we have a particle that is on the right of the fixed point O. Generally, in this chapter, when the particle is on the right, we will say that it has a positive displacement. Okay, so let's say the distance between this particle and the fixed point O is 5 meters. Then since it is on the right of fixed point O, then we say this particle has a displacement of positive 5. If the right-hand side of fixed point O is considered positive displacement, then the left-hand side of the fixed point O will have negative displacement. Let's say you have another particle here. The distance between this particle and the fixed point O is 7 meters, let's say. Then when we talk about displacement, since it is on the left of fixed point O, then the answer for displacement will be negative 7. Okay, when the particle is on the fixed point O itself, then the displacement will be 0. So this is a table that concludes this concept. Generally, later when you see the question say the particle is on the left of point O, then you can write S less than 0, displacement negative. If the particle is on the point O, then S equals to 0. If the particle is on the right of point O, then S will be greater than 0. Okay, let's move on to the next one. Okay, so instantaneous displacement, this is the definition. The displacement of a particle at a certain time. That means, let's say they say, find the instantaneous displacement when t equals to 2. That means find the answer of displacement, find the answer of S when t equals to 2. So you just need to substitute t equals to 2 into the displacement function. The position of the particle, or you can say that the displacement of the particle can be illustrated using a number line and a displacement time graph. So for example, let's say we have an equation, S equals to t squared minus 3t. If you want to draw a number line, let's say we want to draw from t equals to 0 until t equals to 4. To get the answer for displacement, you just need to sub the value of t inside. Then we have all the answers here. I guess no problem. Okay, so later we will meet this kind of question where you have to draw the number line on your own also. So the number line itself is the displacement. The variable on the number line is displacement. So for example, we have the value of displacement -2, 0, and 4. So you just label, okay, based on the number line concept, -2 here, 0, and a bigger number 4 here. Then only you fill in the time. Let's say when t equals to 0, S equals to 0. So this is S equals to 0. So the particle start to move here. So this is t equals to 0. When t equals to 1, S equals to -2. So this is an arrow. The particle moves to the left. So when t equals to 1, S equals to -2. When t equals to 2, S also is equals to -2. That means in between t equals to 1 and t equals to 2, the particle change direction. Okay? Then when t equals to 3, S equals to 0. When t equals to 4, S equals to 4. So this is the number line. And based on the number line, we can identify that when t is in between 0 and 3, the particle, this is the fixed point O. So we notice that the particle is on the left of the fixed point O. Okay, so the answer for displacement will be negative. Okay, now on the left, so S will be negative. For example, S equals to -2, like you can see here. Okay, then when t equals to 0 and t equals to 3, t equals to 0, t equals to 3, the particle is on the fixed point O. So when you want to talk about the value of S, S will be 0. Okay, the next one. When t equals to 3, this is the movement of the particle to the right. So we can identify that when t is greater than 3, then the displacement is positive. Let's say when t equals to 4, S equals to 4. So when the particle is on the right of O, then the displacement will be positive. So this is number line. Next one, the position of the particle can also be illustrated by using a displacement time graph. Let's say we have a displacement time graph here. We use the same set of value, still the same equation, S equals to t squared minus 3t. Okay, if you are the one who draw the graph on your own, I guess you know already this is a quadratic equation. So A is positive, okay, 1t squared. So when you are the one who want to draw on your own, you know that you have to draw a parabola, okay, a U-shaped parabola. Okay, so I just convert all the data here, okay, to become this graph. Okay, now this is the y coordinate, 0, -2, -2, 0, 4. 0, -2, -2, 0, 4. Okay, so the y-axis is displacement and the x-axis is time. Okay, so based on this graph, we also can analyze and identify that when t is in between 0 and 3, we notice that the graph is below the x-axis, or we say that it is below the t-axis in this graph. Okay, that means the y-coordinate of all the points here is negative. Okay, and the y-coordinate is displacement. So that means we identify already when t is in between 0 and 3, the displacement is negative. Okay, now, okay, when t is 0 and 3, we notice that the point is on the t-axis. That means S equals to 0. Okay, then when t is greater than 3, then we notice that the graph is above the x-axis. That means above the t-axis in this graph. Okay, and the y-coordinate of all the points here is positive. Okay, that means the displacement is positive. So we identify when t greater than 3, the displacement is positive. Let's try example 1. A particle moves along a straight line and passes through a fixed point O. The displacement as meter of the particle t seconds after it starts moving is given by S equals to 4 plus 8t minus t squared. Calculate the instantaneous displacement in meter and determine the position of the particle from point O when t equals to 0. So when they ask about instantaneous displacement, you just have to substitute the value of t into the displacement equation. So when t equals to 0, we just sub the position of t, we sub 0. Then we will have answer S equals to 4 meter. And for this question, they ask us to determine the position of the particle. So positive 4, that means the particle is on the right-hand side, 4 meter to the right from the fixed point O. Okay, next one, part B. Find the instantaneous displacement when t equals to 10. So same thing, you just have to sub t equals to 10 into the S equation. After you press calculator, we will have answer S equals to -16. Negative, that means the particle is on the left of the fixed point O. So you can mention it is located 16
a particle moves
along a straight line and passes through a fixed point O. Its displacement S meter is given by S equals to 2t squared minus 5t minus 3. where t is the time in seconds after the movement begins. Find the instantaneous displacement in meter of the particle when t equals to 0 and t equals to 2. So this is similar to example 1. So for instantaneous displacement means the displacement, the answer of displacement when t equals to 0. So you just need to do substitution, sub t equals to 0 into the displacement equation. Then we will have the answer s equals to -3 meter. Same goes to part 2. When t equals to 2, so you just need to do substitution, sub the value of t2 into the displacement equation. Then we have answer s equals to -5. Okay, next one, part B. Find the time when the particle passes through point O. Passes through point O. For point O, it is s equals to 0. So when s equals to 0, they ask you to find back the value of t. So we do when s equals to 0. This is the displacement equation, 2t squared minus 5t minus 3. Okay, we form a general form and do factorization. So we have two answers for t, and time, the answer for time must be either 0 or positive. So we have to ignore t equals to -12. Okay, that's all. This is the answer. And then part 2, find the time when the particle is 9 meters to the right of point O. Okay, 9 meters to the right means s equals to +9. Okay, so s equals to +9. You substitute the displacement equation, 2t squared minus 5t minus 3 here equals to 9. And then we form general form. 9 bring to the other side become -9. 9, -3, -9, we have -12. Then we do factorization. So same here, we have to ignore the negative answer for t. So the answer is only t equals to 4. Then part C, determine the range of time in seconds when the particle is to the right of point O. To the right of point O, they didn't mention like previously, they said 9 meters to the right. So for 9 meters to the right, we know s equals to +9. They just say the particle is to the right. So from this sentence, we analyze and we notice that s is greater than 0. Okay, so we put s greater than 0 and you sub the displacement equation, let it be greater than 0 and do factorization. This is quadratic inequality, so you have to do either graph sketching method or number line method to get the range of values of t. So the easiest way is to do graph sketching method. So I draw the parabola, 2t squared, 2 is positive, so we draw a U-shaped parabola. The variable here is t. Okay, the x-intercept is -12 and 3. Okay, so inequality greater than 0. Greater than 0 means we choose the graph that is above the x-axis, means above the t-axis in this case. Okay, so we choose these two regions. Okay, so we have two answers for t, and again, t can only be either 0 or positive, so we only accept t greater than 3 and ignore t less than -12. Example 3, a particle moves along a straight line and passes through a fixed point O. Basically, it means that when t equals to 0, s equals to 0, because the particle starts moving at fixed point O. Okay, its displacement s meter t seconds after passing point O is given by s equals to 4t minus t squared for t in between 0 and 5. Represent the displacement of the particle by using the number line and the displacement time. So first of all, you can draw a table and label all the t value here, and you can do substitution one by one. When t equals to 0, you sub into the displacement equation, and we get the answer for s equals to 0. When t equals to 1, substitute inside, we have answer s equals to 3, and so on. Okay, so from this table, we identify that 2, 4 is the maximum point. And let's check the equation again. S equals to 4t minus t squared. When you rearrange the equation, you will notice that this is actually S equals to negative t squared plus 4t. Means when you yourself have to draw the displacement time graph later, you know that you have to draw an N-shaped parabola because A is negative 1. Okay, so to be very secure that 2, 4 is really the maximum point, you want to identify whether 2, 4 is really the maximum point, you can do one more step. We can do differentiation and let it be 0 and to find the value of t. So this is S equals to 4t minus t squared. We do differentiation. We have 4 minus 2t. Then we let it be 0. 4 minus 2t equals to 0. We have answer t equals to 2. So by doing so, you are so sure that when t equals to 2, you have your maximum value 4. Okay, means now you won't be like guessing whether t equals to 1.5 will be the maximum point or t equals to 2.5 will be the maximum point. Okay, now we are so sure that 2, 4 is the maximum point. We know our answer is correct. Okay, then only we continue. For part A, we need to draw the number line. So for the number line, displacement is the value on the line. So we identify for number line, -5, 0, 3, and 4 is the value of displacement. So you label -5, 0, 3, and 4. After that, then only you fill in the time. When t equals to 0, s equals to 0. So this is s equals to 0. You start your particle here, t equals to 0. When t equals to 1, s equals to 3. So this is s equals to 3. So you draw your particle here. Okay, so the particle moves from here to here. So you can draw your arrow like this. Okay, when t equals to 2, s equals to 4. When t equals to 3, s equals to 3. So we see these two answers are the same. Okay, and just now we identify already 2, 4 is the maximum point. And you see I write the word v here. ds dt is also equals to velocity. Later we will learn in the next part. When velocity equals to 0, that means the particle stops or change direction. So when v equals to 0, t equals to 2, that means we identify that the particle changes direction when t equals to 2. That's why you can draw your particle here when t equals to 2. Then we just continue. When t equals to 4, s equals to 0. When t equals to 5, s equals to -5. So this is the number line. Okay, the next one, part B. Using the same value, we draw the displacement time graph. Okay, so you just need to plot your point one by one. Your x-axis is time and y-axis is displacement. So you just plot and draw a very nice parabola. And your 2, 4 is the maximum point. Determining the total distance traveled by a particle within a given period of time. First of all, the total distance traveled by the particle in the first n seconds means the total distance traveled by the particle from t equals to 0 to t equals to n. For example, when the question asks you to find the total distance traveled by the particle in the first 5 seconds, means you calculate from t equals to 0 until t equals to 5. That means you can do your working modulus of S5 minus S0. That means you substitute t equals to 5 into the displacement equation, minus you substitute 0 into the displacement equation. Then you'll get the answer for distance. And because distance is a scalar quantity, so the answer must be positive. S is position. So sometimes maybe the answer here is -9 and the answer here is 2. -9 minus 2, you get answer -11, for example. Then you have to do modulus and change it to +11. So the total distance traveled will be positive. positive 11 meter, for example. Okay, next one. The distance traveled in the nth second is the distance traveled from t equals to n minus 1 to t equals to n. Then you can use this formula, modulus of Sn minus Sn minus 1. That means, for example, if the question asks you to find the distance traveled by the particle in the 5th second, in the 5th second means from the 4th second to the 5th second, how many meter it moves. So you can do S5 minus S4. If in the 7th second, then you do S7 minus S6 and so on. So same thing, distance is a scalar quantity and S basically is just a position. So maybe sometimes the value inside is negative. Then you have to put modulus and make sure that your final answer is positive. Okay, next one. The displacement at t equals to n is not necessarily the same as the total distance traveled in the first n seconds. So for the displacement at t equals to n, for example, they ask you what's the answer for s when t equals to 4. So you substitute the value of 4 into the displacement equation and you get your answer, let's say s equals to 15. Okay, whereas another question, let's say they say, find the total distance traveled in the first 4 seconds. Okay, just now is the answer of s when t equals to 4. Now is the total distance in the first 4 seconds. Your working will be S4 minus S0 modulus, like just now, the first one. And the answer may not be 15. Okay, let's say here the answer is 15 minus answer 4, maybe S0 answer is 4. So you will have 15 minus 4, answer 11. So their answers may not be the same. Okay, so next one. The total distance traveled by the particle in a given period of time can be determined by drawing a number line or sketching a displacement function graph. That means you can draw a number line, and from the number line, you calculate the total distance traveled. Or you can draw a displacement time graph. Then after that, you can calculate the total distance traveled. Okay, and next one, second method, you can also identify the time when the particle changes direction. After that, you can use this method to find the total distance traveled. Example A, we have an equation s equals to t squared minus 6t. Find the total distance in meter traveled by the particle in the first 7 seconds. So first of all, if you would like to use the number line method to calculate the total distance traveled, then we have to check the information given is find the total distance traveled in the first 7 seconds. So you can draw a table like this and then fill in the time from 0 to 7. And then you'll find the answer for displacement one by one by doing substitution. So for example, when t equals to 0, we substitute inside, we have answer s equals to 0. T equals to 1, we have answer s equals to -5, and so on. After that, you can draw the number line. Okay, so the line itself is the displacement. So we check the answer for displacement, -9, -8, -5, 0, 7. -9, -8, -5, 0, 7. And then you fill in the time one by one. When t equals to 0, s equals to 0. T equals to 1, s equals to -5. Okay, then the minimum point is 3, -9. When t equals to 3, s equals to -9, and so on. When t equals to 4, s return to -8. And then when t equals to 7, s equals to 7. So this is the number line. After that, you can find the total distance traveled. Okay, so from here, you can notice that the particle changes direction when t equals to 3. So when you find the total distance traveled, you can divide it into 2 different parts. Okay, this part, you can use a larger number minus a smaller number when you find the total distance traveled. So this is s equals to 0. and this is s equals to -9. So for this part, we can use 0 minus -9. After that, the particle changes direction. So this is s equals to -9, and then it stops at s equals to 7. So we can use a larger number minus a smaller number, 7 minus -9. Then we have answer total distance traveled is 25 meters. Okay, so this is number line method. Another method is you can draw a displacement time graph to find the total distance traveled. So same thing, they give us the information in the first 7 seconds. So you also can draw a table like this, and then you plot the point into your graph. So we have 0, 0, 3, -9, and then 6, 0. You can label on your own. This is 6, and then 7, 7. Okay, so y-axis is displacement. Then now you also can find the total distance traveled. Okay, displacement is y coordinate, so you just have to look at the y coordinate, and same thing, we use a larger number minus a smaller number. So 0 minus -9. Okay, after that, the particle changes direction. Okay, so from this part to this part, the s value here is 7, and then the s value here is -9. So plus 7 minus -9. So we have answer, total distance traveled is 25 meters. Another method to find the total distance traveled by the particle will be, we can identify when the particle changes direction first. Okay. When a particle stops or changes direction, velocity will be equals to 0. So we have an equation s equals to t squared minus 6t. To get velocity, we just need to do differentiation of displacement. So we do ds dt. Then we get answer 2t minus 6. Okay, so when v equals to 0, that means ds dt equals to 0. We have answer t equals to 3. So from here, we identify already, when t equals to 3, this particle will change direction. Like from the drawing itself, you also identify like this. When t equals to 3, the particle changes direction. Okay, so when we find the total distance traveled, we cannot find one shot s7 minus s0 because it turns in the middle. Okay, so since it changes direction when t equals to 3, so you can do the working like this, s3 minus s0 plus s7 minus s3. Okay, it's something like this, similar to the graph. This is when t equals to 3, the answer for displacement. So this is s3, and this is s0. So you are doing s3 minus s0 also. And this is s7, and this is s3. So here you are actually also doing s7 minus s3. Okay, so we do this because for this method, we are not going to draw the graph. So by identifying the time when the particle changes direction, we can separate the working to become like this. And then you just need to do substitution. S3 means you substitute the value of t equals to 3 into the displacement equation. So we have 3 squared minus 6 times 3. Minus S0 means t equals to 0. Okay, plus S7 minus S3. So the value of t equals to 7, you sub here. And then minus S3. So t equals to 3, you sub inside here. Then we have answer 25 also. Example 4. The displacement of a particle is given by s equals to 6t minus t squared plus 7. The particle moves to the right of O until t equals to 3, and then moves towards O again. That means the particle changes direction when t equals to 3. Find the total distance in meter traveled by the particle in the first 2 seconds. So since the particle changes direction only when t equals to 3, so when they ask you to find the total distance in the first 2 seconds, you just need to do modulus of S2 minus S0. So for S0, we sub t equals to 0 into the equation. We have answer S equals to 7. S2, we just need to substitute t equals to 2 into the equation. We get S2 equals to 15. So we have modulus of 15 minus 7, answer 8 meter. Okay, so please bear in mind that S0 may not be 0 every time. So it's very important to find S0 also. Okay, so for this case, S0 is 7, then only you substitute inside. Okay, part 2. Find the total distance traveled by the particle in the first 9 seconds. So for this question, the particle changes direction when t equals to 3. So when they ask you to find the total distance in the first 9 seconds, you have to separate your working into 2 different parts. Okay, modulus of S3 minus S0 plus modulus of S9 minus S3, because it changes direction when t equals to 3. So this is the displacement of the particle when t equals to 3 minus the displacement of the particle when t equals to 0. Plus, let's say here, the displacement of the particle when t equals to 9 minus the displacement of the particle when t equals to 3. Okay, so you can find one by one. For S0, because we found already just now, so I just list out S0 is 7. S3, just do substitution. We have answer 16. S9, also just do substitution. We have answer negative 20. Okay, then we substitute the value here. S3 minus S0, 16 minus 7. S9 minus S3, we have negative 20 minus 16. So here, modulus of negative 36 will give you positive 36. So we have answer total distance traveled is 45 meters. Okay, next one, part B. Find the distance traveled by the particle at the 7th second. Okay, distance traveled at the 7th second means from the 6th second to the 7th second. So you can write T7 equals to modulus of S7 minus S6. Okay, you can also do your working like this. You do your substitution in the modulus instead of find the answer, then only sub into the modulus. So S7, you just have to substitute 7 here and get your answer. Minus S6, substitute 6 into the T position. Then we have answer negative 7. So modulus of negative 7 will give you answer positive 7. Example 5. Shaza cycles her 3-wheel bicycle in a straight line at her house backyard and has an initial displacement of 2 meters from a flower pot. Whenever you see the word initial, means at the beginning, means when t equals to 0. So this means when t equals to 0, s equals to 2. From a flower pot, that means in this case, the flower pot is like the fixed point O. At the flower pot, s equals to 0. And Shaza is here in the beginning, 2 meters to the right of the flower pot. So 2 meters from the fixed point O. Okay, her displacement s meter t seconds after passing the flower pot is given by s equals to t power 3 plus 2t plus c. Determine the value of c. So for part A, you just need to make use of this information. When t equals to 0, s equals to 2. So we just substitute s, we sub 2, t, we sub 0. Then we have answer c equals to 2. Okay, then B1. Find the distance of Shaza from the flower pot when t equals to 2. Okay, so we got the answer c equals to 2. So this is the complete equation of displacement. S equals to t power 3 plus 2t plus 2. So we substitute t equals to 2 into the equation. We have answer s equals to 14. Find the distance of Shaza from the flower pot. And just now we identify already at the position of flower pot, s equals to 0. That's why to find the distance, we use 14 minus 0. We get answer 14 meters. Okay, so this is the answer. Please don't do S2 minus S0 in this case, because S0 answer is 2 for this question, and the answer represents the original position of Shaza, not the position of flower pot. Okay, I hope no problem. The next one, B2. Find the distance of Shaza from the flower pot when t equals to 3. So same thing, you just have to sub t equals to 3 into the equation. Then we have answer 35 meter. Find the distance. So 35 minus the position of flower pot 0. So we have answer 35 meter. Example 6. The displacement of a particle is given by s equals to 4t squared plus t. Calculate the total distance in meter traveled by the particle when t is in between 0 to 4. So I will always use this method. I will firstly identify whether the particle changes direction or not. Okay, so when the particle stops or changes direction, v will be 0. So I do differentiation to get velocity. So we have 8t plus 1. Okay, we let v equals to 0. We have 8t plus 1 equals to 0. T equals to negative 1 over 8. When you look at this equation as a normal quadratic equation with a equals to positive 4, then the value of t equals to negative 1 over 8 means the minimum point occurs when t equals to negative 1 over 8. But back to the context here, t is time in this case, and time cannot be negative. So that's why we have to put ignore. That means in this case, the particle won't change direction. So when they ask us to find the total distance traveled by the particle, when t is in between 0 to 4, you just have to do S4 minus S0 modulus. Okay, so we just sub t equals to 4 into the equation, minus substitute t equals to 0 into the equation. Then we have answer 68 meter. Same goes to part B. Find the total distance traveled from t equals to 3 to t equals to 6. You just have to do S6 minus S3. So 6 we sub into the equation, minus 3 we sub into the equation. Then we have answer 111 meter. Example 7. A particle moves along a straight line. At time t seconds after it starts moving, its displacement s meter from the fixed point O is given by s equals to t minus 2 squared plus 5. So part A, copy and complete the table below. So this is very easy. You just need to do substitution. When t equals to 0, you sub here. Then we get answer s equals to 9. Okay, let's say 6. When t equals to 6, you do substitution. Then we have answer 21. Okay, the next one, B. Sketch the displacement time graph for t in between 0 to 6. Okay, so for this question, we don't need to do something like this. Don't need to do differentiation method. It's because this equation is already in vertex form. Okay, so you can straight away identify the answer for minimum point by just looking at the equation. So the minimum point is 2, 5. So you are so sure that the minimum point occurs when t equals to 2, means it won't be when t equals to 1.5 or when t equals to 2.8 and so on. Exactly when t equals to 2, we have minimum point. So you can just draw the displacement time graph straight away based on your reading just now. So just plot the point and draw the graph. Okay, so x-axis is t, and then y-axis is displacement s. Next one, C. Calculate the total distance in meter traveled by the particle in the first 6 seconds. So since you have already drawn the displacement time graph, you can identify the total distance traveled by just looking at the graph. Okay, so this is the position where the particle changes direction. So when we want to calculate the total distance traveled, you can divide it into 2 different parts. Okay, from here to here, we just look at the y coordinate. That means the value of displacement. So the value of displacement is 9. And for this point, the value of displacement is 5. So 9 minus 5. Plus another part from here to here, the value of displacement is 21. Okay, and then for the minimum point, the value of displacement is 5. So plus 21 minus 5. Then total, we have the answer 20 meter. Example 8. The displacement of a particle is given by s equals to 2t squared plus t. Calculate the displacement of the particle when t equals to 3. So this is like calculate the instantaneous displacement when t equals to 3. Okay, we just have to do substitution, sub t equals to 3 into the equation. Then we have answer s equals to 21 meter. Part B, calculate the total distance traveled by the particle in the first 5 seconds. If you don't want to draw the number line and also don't want to draw the displacement time graph, then I suggest you to do differentiation first. Okay, when the particle changes direction, v will be 0. So we want to identify whether the particle changes direction or not within these first 5 seconds. We do differentiation. V means ds dt. So differentiate, we have answer 4t plus 1. When 4t plus 1 equals to 0, we have t equals to negative 1 over 4. Time cannot be negative, so ignored. Okay, that means we identify already the particle won't change direction. So when you want to find the total distance, you just have to do S5 minus S0 modulus. Okay, so t equals to 5, substitute into the equation, minus t equals to 0, substitute into the equation. Then we have answer 55 meter.